Conventional computers are a part of our lives every day. We use them to communicate, run simulations, and play games. Scientists are making computers smaller and smaller every day. Because the smaller we can make computers, the faster and more powerful they'll become. But it seems as if the laws of physics are limiting the size of a computer down to about the size of an atom. But what if we can use quantum mechanics to overcome the limitations of modern technology? To understand computers, first we need to understand how they communicate. They communicate in a language called binary, just how you and I communicate in languages like Spanish and English. Binary is a very simple language, using two characters, a 1 and a 0. These are called bits. Bits can be arranged in different configurations to represent different values. With 4 bits, I can represent 16 different values, ranging from 0 through 15. Now that we understand binary and how computers communicate, we need to understand what computers are made of. The basic components of computers consist of processors, which are composed of logic gates, which are made of transistors. Transistors are the smallest part of the computer. And processors are made up of multiple transistors, and when there's more transistors, the processors can make more operations and calculations, making the computer faster and more powerful. Transistors act like a gate. They either let bits through, or the gate is closed and they block them. The problem when we make transistors about the size of an atom, when bits are supposed to be blocked by the gate, they can jump over the gate. This is known as quantum tunneling. Instead of working against the challenges of quantum mechanics, scientists have decided to use them to their advantage to overcome quantum tunneling. Instead of going smaller, scientists have decided to change the conventional bit itself. Here's my 1 and 0. Scientists have developed the quantum bit, which can represent the 1 and 0 at the same time. The quantum bit can also represent an infinite values in between 1 and 0 and multiple values at the same time. What does all this mean? It means that the quantum bit can hold more values than the conventional bits. Conventional computers process in series, which means 1 bit at a time, 1 calculation at a time, and 1 operation at a time. Quantum computers calculate in parallel, which means multiple values at a time, which means that the quantum computers can calculate multiple operations and calculations all at the same time. This makes quantum computers hundreds of thousands of times faster than conventional computers.